Oh, hi again. Mr. Hinton here for the rest of Pod 4, Part 2, where we get into simplifying expressions. Let's just get on it. So our objectives are to use all of our properties, including distributive property, to simplify expressions and combine like terms. The distributive property is used with addition to simplify expressions. So you can see here, we multiply through with this 3 through the parentheses times each of the terms inside. 3 times 4, 3 times 8. Over here, the A is multiplied times B, and A is multiplied times C, giving us AC. That's distributive property. We're going to do a lot of that. It also works with subtraction. It works when there's more than 2 things inside parentheses. You could have 3 things or 5 things or whatever. You just take the thing outside and multiply it times each of the terms inside. The terms of an expression are the parts to be added or subtracted. So terms are separated by pluses and minuses. Now this is very important. Like terms. Like terms are terms that contain the same variables raised to the same powers. You're going to hear me say that over and over. The same variables raised to the same powers. That's what makes them like terms. And whenever you have like terms, you want to combine them together. So in this example, the 4x to the first and the 3x to the first. These two terms both have an x to the first power. They are like terms. This 2 does not have an x with it. We call this a constant because it does not have a variable. It is not a like term with these two, but we can combine these two together. How do you combine them? You combine their coefficients. The coefficients are the numbers in front. The 4 and the 3 are coefficients. You can combine them together. Like I said, 2 is a constant. If you combine these, 4 minus 3 is 1x, so we would have a 1x minus 2. Okay, coefficient, I said, is the number that comes in front of the variables. It's multiplied by the variables. Like terms can have different coefficients, and those coefficients are what you combine. When you have a variable just by itself, for example, just an x, that coefficient is 1. It's a 1x. Or if you just have a by itself, it's a 1a. So this x squared can be just written x squared, or you can put a 1x squared in front of it. The 1 and the 3 are called the coefficients in this case. Are these like terms? Well, this has an x and this has an x. So they both have the same variables, but this one is raised to the second power. This one is raised to the first power. They do not have the same powers. They have to have both, the same variables raised to the same powers, to be like terms. These would not be like terms. Okay, simplify the expression by combining like terms. First off, are these like terms? This is 72p to what power? What exponent is here? Since there's no exponent that shows up, it's p to the first. This one is also p to the first. They have the same variables. They're raised to the same powers. We can combine them by combining the coefficients, 72 minus 25. And that's going to give us a 47p. That's simplified. We combined like terms. Next thing, are these like terms? Well, I see 3/4 x to the 4th, and what number's in front of this? A 1x to the 4th. They both have x to the 4th, so they are like terms. I can combine 3/4 and 1 by adding them together. So that's what they're going to show me here. And the x to the 4ths are what makes it be like terms. Then we combine the 3/4 and the 1. In order to do that, we have to get a common denominator. So we change 1 to be 4 over 4. Then we can add the 3 plus 4 on top, giving me a 7. The denominator does not change. 7/4 x to the 4th. Okay, are these like terms? Well, this has an m, this has an n. They are not like terms because they do not have the same variables. They're not like terms, so you cannot combine them together. There's nothing you can do with that to simplify it. Okay, looking at this, we need to simplify the expression by combining like terms. I'm going to get my pen tool over here. Well, let's back up a little bit. Okay, if I can get my pen tool to work. Come on. There we go. Okay, there's my pen. Okay, here is a 3x squared. Are there any other x squareds? Well, here is a minus 1x squared. Those two are like terms because they both have an x squared in them. I can combine them by saying 3 minus 1 is 2x squared. When you are combining like terms, the exponents don't change. What's next? Well, here I have a 5x to the first power, and it's a plus or a positive 5x. Here is a plus 11x to the first power. They both have an x to the first power. They are like terms. I can combine a positive 5 plus 11. That is a plus 16x. Here I have I'll use boxes. Here I have a plus 7, a constant. It does not have a variable. And a minus 13 does not have a variable. It's also a constant. So I can combine these together. A positive 7 minus 13 is minus 6. I have simplified that expression by combining like terms. Okay, one more. Simplify this expression by using the distributive property and then combining like terms. Distributive property, I'm going to take 9 and I'm going to multiply it through the parentheses. 9 times x is 9x. 9 times 7 is 63, and it's a positive 63, so I put plus 63. Then I'm going to multiply this negative 3. That negative goes with it. A negative 3 times 2x, and then a negative 3 times a negative 6. Negative 3 times 2x is negative 6x. Negative 3 times negative 6, a negative times a negative is a positive. 3 times 6 is 18. Finally, do the same thing here. I'm going to multiply this. It's a positive 4. So a 4 times 2x and a 4 times a negative 5. 4 times 2x is a positive, so I put a plus 8x. 4 times negative 5 is negative 20, so I put a minus 20. Now I need to combine like terms. I have a 9x to the first power here, a minus 6x to the first power here, and a plus 8x to the first power here. So, combining 9x minus 6x, combining 9x minus 6x, that's 3x, plus 8x then from over here. That gives me 3 plus 8 is 11x. I have a constant here of a plus 63, a plus 18, a minus 20. 63 plus 18 is 81. Minus 20 is plus a positive 61. So my answer here, 11x plus 61. That's it for now. We'll see you guys later. Bye.